Hi, I'm Nick,
I'm Cassandra.
And I'm Bella.
and our presentation is the eruption of Santorini in 1646 BC. So the type of disaster that this eruption is a geophysical because it is a volcanic eruption. And geophysical disasters are disasters brought about by tectonic and seismic activity below Earth's surface. These types of disasters can also trigger another geophysical disaster, which I will get into briefly. So the location of where this event occurred is in present-day Santorini, which is a Greek island in the Mediterranean located on the southern side of the Aegean Sea. But when the eruption actually occurred, the place was referred to as Thera. So what actually happened? Prior to the eruption, the Thera volcano was in the eruption process cycle. Geological evidence shows that the volcano erupted numerous times over several hundred thousand years before the Minoan eruption actually occurred. In this repeated process, the volcano would violently erupt and then eventually collapse into a somewhat circular seawater-filled caldera with numerous small islands forming a circle. The caldera would slowly refill with magma, which would result in the building of a new volcano, which would eventually erupt and then collapse, going over and over in a process. Immediately prior to the Minoan eruption, the walls of the caldera formed a nearly continuous rings of islands with only an entrance between Thera and the small island of Aspronici. The eruption itself had a strength of roughly 40 atomic bombs, which is approximately 100 times more powerful than the eruption at Pompeii. And this is what gave this eruption a 6 or 7 on the volcanic explosivity index. This eruption was a Plinian eruption, and it resulted in a 30 to 35 kilometer high plume, which went all the way into the stratosphere. And the magma that was underlying the volcano came into contact with the shallow marine embayment, which resulted in a violent steam eruption as well. The dense rock equivalent, or DRE, is a total volume of the material erupted from the volcano. And the volume of the ejecta was approximately 100 cubic kilometers. And the majority of the ashfall went in the direction of east and northeast from Santorini. And it was so dense that the ash and pumice completely covered a town, the town of Akrotiri that was in Thera. And this, as I mentioned earlier, geophysical disasters can cause another geophysical disaster, and that's exactly what the Minoan eruption did. It caused a 35 to 150 meter tall tsunami that devastated surrounding coastal areas such as the north coast of Crete, which was 110 kilometers away. So the eruption was so powerful, it completely altered the topography of then Thera, and some have argued that it has rendered the island sterile.
So what triggered this eruption? The island of Santorini is the southernmost volcanic center on the South Aegean volcanic arc in Greece. It is a shield volcano that lies on continental crust within a 40-kilometer wide northeast to southwest rift zone of normal to right lateral transtensional faults. The location of Santorini in a seismically active continental rift zone creates the possibility that the magnet chambers underneath the Kameni line were created by episodes of tectonic rifting. The tectonic activity, combined with the basalt injection that will be explained in the following slide, is what is believed to have triggered the eruption. The eruption was triggered in reservoirs along a surface expression of a basement fault known as the Kameni line. Below the Kameni line, there is a rhyodactic magma reservoir. Within this reservoir, the buildup of the Minoan eruption began decades to centuries prior to 1646 BC. For centuries, this reservoir inflated due to the repeated injection of hot silicone magma, which mixed and homogenized with the existing magma in the reservoir. Along the side of the reservoir, as you can see in this figure, is an intrusion of barium-rich andesite and diorite that lies beneath the northeast end of the Kameni line. The rhyodacite interacted with and exploited the andesite to create coliform and tabular enclaves. This created a mushy intrusion that allowed the rhyodacite to reach the surface and initiate the eruption. The volcano erupted in 4 phases. Phase 0 left 2 lapilli fall layers that together measured 10 centimeters thick. These 2 layers came from a subplinian plume that was 7 to 10 kilometers high. This possibly warned the Minoan population of the following eruptions and allowed them to evacuate in time. Phase 1 led at a Plinian pumice fall deposit that was up to 5.5 meters thick. During Phase 2, the seawater that invaded the vent created pyroclastic surges, which caused shallow, powerful explosions. This phase was larger and widened the pre-Kameni Shield volcano further north. Phase 3 began and had pyroclastic flows instead of surges. This flow produced ignimbrite, which is a pyroclastic flow deposit that is rich in pumice and glass shards. Finally, in Phase 4, powerful eruptions empty the magma chamber until the vent collapses in on itself.
So, to go over some statistical facts, this eruption had a magnitude of between 6 and 7 on the Volcanic Explosivity Index, which is very extreme. This caused an ejection of about 60 kilometers cubed of dense rock equivalent, which is just the volume of magma ejected as pumice and volcanic ash. The eruption column is estimated to have been between 30 to 35 kilometers high and reaching all the way up to the stratosphere. Also, 35 to 150 meter high tsunami waves were generated, devastating nearby coastal cities and islands. And as many as 20,000 people were killed. Injuries and economic losses are virtually unknown due to how long ago this event occurred. So, what have we learned from the eruption at Santorini? Well, archaeologists have been able to discover more information about Greece's Bronze Age, which was a mystery for many years, through the uncovering of the city Akrotiri in Thera, which is presently Santorini, where the eruption took place. It is now considered an important marker horizon for the Bronze Age chronology. The site unveiled, surprisingly, no human remains. Evidence shows that citizens had begun to do some repair work to their dwellings because of minor damage, but before the major eruption, some had time to take their most valued possessions and leave. They either successfully reached safety, were buried elsewhere, or got swept away by tsunami waves. While the site did not yield an abundance of gold, silver, or bronze artifacts, well-preserved frescoes, which were protected by a layer of ash, reveal a visual legacy. The art depicts everyday life and events in Akrotiri, such as the rigging of ships, how people were dressed, religious practices, interpersonal interactions, and various tools and weapons. Several impacts resulted from this major eruption. To start, it blew out the interior of the island and forever altered its topography. After all, its force, as stated earlier, is estimated to have been the equivalent of 40 atomic bombs. The eruption appears to have made an impact on Greek culture as well, inspiring the Titanomachy myths and Hesiod's theogony, and Plato's story of Atlantis. It also devastated the nearby Minoan populations, most likely through the following tsunami or earthquake. The exact date of the eruption is debated amongst scientists, so the following are merely hypotheses. Around the time of the radiocarbon indicated date of the eruption, there is evidence for a significant climatic event in the northern hemisphere, including the failure of crops in China. A volcanic winter from an eruption in the late 17th century BC seems to correlate with Chinese records that detail the collapse of the Shah dynasty. Apocalyptic rainstorms in Egypt have been attributed to short-term climatic changes from the Santorini eruption. And finally, psychologist Julian Jaynes proposed that the eruption was a crucial event in the development of human consciousness, since the displacements that it caused led to new and important interactions among certain communities. This is a controversial bicameralism hypothesis, and it is interesting to think about. Thanks for watching a presentation on the eruption at Santorini.